The first example of a stoichiometry problem is going to ask us how many grams of iron 3 oxide can be produced from 142 grams of pure iron. You have unlimited oxygen, which means you don't have to worry about it in your calculations. The first thing you need to do is make sure your equation is balanced. This one is not. So I'm going to put a 3 here and a 2 here, and I've got 4 irons on the right, so I'm going to need 4 irons on the left. Now that it's balanced, we can continue. The first thing you need to do is to start with what you know. I'm going to map out this stoichiometry problem first. I'm going to have to go from grams of pure iron, because that's what it says in the problem. I'm going to go from grams of pure iron to moles of iron. When you do stoichiometry, you always have to get to moles and then go from moles of one thing to moles of another thing. And that other thing in this case is what we care about, which is the iron 3 oxide. So that's Fe2O3. And once you're in moles of what you're going to, the last step is to actually get there. It asks us for how many grams of iron 3 oxide, so I'm going to put G of Fe2O3. This is the map. I'm going to map out one more thing with this. To go from grams of something to moles or something, you've got to use the molar mass. In this case, we're using the molar mass of iron. To go from moles of one thing to moles of another thing, you've got to use the balanced equation, which I'm going to abbreviate as BEQ. You have to use the balanced equation. And what part of the balanced equation are you using to go from moles of one thing to moles of whatever else you're looking for? You use the molar coefficients, which are the big numbers in front. That's what's going to get you from moles of one thing to moles of your other thing. And then once you are in moles of that new thing where you are heading towards, you're almost there, because then you got to go from moles to grams. And to go from moles to grams, or from grams to moles, you use the molar mass again. In this case, we're using the molar mass of Fe2O3. So I'm going to rewrite this down here so we have all the room we need. The equation we're looking for is 4 Fe, which is a solid, iron is solid, reacts with oxygen gas, 3O2, to produce rust, which is iron 3 oxide. We have 142 grams of iron. Always start with what you know, so let's scroll up a bit. We have 142 grams of pure iron. That's the only thing we know. And when I say start with what you know, that means start with the number that's given in the problem. 142 grams of pure iron. 142 grams of pure iron, what you know, goes over 1. The next step is to write your units so that the units will cancel. We do not want grams of pure iron, so I'm going to write GFE at the bottom. That way it will end up canceling out. To go from grams of iron to moles of iron, I'm going to write moles, MOL, of iron, Fe, above that. 1 mole of iron has a molar mass of 55.85 grams per mole. That's according to the periodic table. I have moles of iron, and at this point, to get out of moles of iron, I need to get over to moles of iron 3 oxide. Looking at our balanced equation, I see that 4 moles of pure iron combines with 3 moles of oxygen to give 2 moles of iron 3 oxide. For this part of your conversion, where you've got moles of one thing over moles of another thing, you've got to use the molar coefficients from the balanced equation. Next to the moles of iron, you have a 4. Next to the moles of iron 3 oxide, you've got a 2. That's all you got to do for that step, is just plug in what you see from the balanced equation. The last step in our conversion tree is to get rid of moles of iron 3 oxide, because the question doesn't ask us for moles of iron 3 oxide, it asks us for grams of iron 3 oxide. And we're familiar with the fact that if we're given moles, we can go to anything. We're going from moles to grams. So grams of Fe2O3. Let's make sure we're still canceling things out. Moles of iron canceled top and bottom. Moles of Fe2O3 canceled top and bottom. What did not cancel is grams of Fe2O3, and that's a good thing because that's what we want. What is the molar mass of 1 mole of Fe2O3? According to your periodic table, add up 2 irons and 3 oxygens, and you'll get 159.7. The next step is just doing the math and making sure that you have your order of operations correct, using parentheses or whatever your technique is. And your answer, when you do all that math, is 203 grams of Fe2O3. This part right here that I highlighted in blue earlier, I call this the turning point, because when you have moles of something over moles of something else, that's where the problem kind of turns from being about one thing to being about another thing. Stoichiometry isn't very difficult, but it can become very difficult if you forget to balance your equation, or if you mix up where the 1 and the molar mass go for moles. Always make sure that your units cancel top and bottom so that you are left with what it's actually asking for. We did not use Avogadro's number. We did not use 6.02 times 10 to the 23 because this problem did not ask us about how many formula units of Fe2O3 were created, or how many molecules or atoms of iron were present. Remember that you only use Avogadro's number when you're dealing with particles or something. This was only asking about moles and grams and how we get through the mole from grams to grams. So we don't use Avogadro's number, we instead use the molar mass.